Okay, so I'm showing my screen now. So yeah, this talk, we're going to go through creation of APIs, forms, and talk a little bit about how we can develop web applications or provide assistance to web applications through the Wolfram Cloud. So let's kind of jump right in with some motivation for this. So, the big picture for web development is that we want to share material with other users, right? With people who come to our web pages to look at them. So this could be content such as text, data, images, graphics, graphs, etc. In the case of something like an API or a more sophisticated web application, we maybe want to have a function that does an evaluation for some sort of computation that we're interested in. Maybe there's an interactive GUI, something on the web page that we can play with or tinker with to get some insight about the idea that's presented on the web page, to kind of these much bigger scale web applications. And we'll give some, I'll just kind of mention some examples and we'll show some examples later on, but bigger and bigger and more sophisticated web pages. Okay, and another case that we'll talk about is just, if you already have an existing web application that you've been developing and you just want to add some Wolfram language capability to it, this will be giving some tools here about how to do those computations and insert them into your existing web application. Okay, so yeah, let's kind of start with kind of the basics and then we'll build from that. So, right, sharing content on the internet. So the early days of the internet, or we have these very simple web pages with static content, maybe some text, some graphics, images, and so forth. And these are embedded in this HTML, right? So this is a hypertext markup language. So all the information in your web page is kind of stored in between these tags, which tells the browser how we want this information to be rendered. So, I mean, some of you, I'm sure, have not played with HTML at all, but this is sort of, your very, very basic web page, what it would look like. So we would have H1 is just a header tag. So we'd have a header that says my web page, and then a paragraph that says I wrote this web page in 2 minutes. And if we save this as a file and open it up in a web browser, we would see a formatted web page, just that simple. Of course, this gets much more complicated in modern web pages and applications. So, right, these have dynamic content, respond to user inputs. A lot of cases in commercial websites, we would have advertising that we want to insert into the page based on the users who are visiting the page. So just some common examples that I'm sure most of us are familiar with: Facebook, Google, Gmail, that sort of thing. Any games that you would want to play through your browser would have this type of much more sophisticated content, which requires another level of programming in order to make it work. So, not only in that case would we have HTML in those pages, but we'd also have JavaScript, which would be running on your browser as data is coming in to react and respond to user inputs. And JavaScript is kind of a whole nother ecosystem in itself, which has a number of frameworks built on top of it. And I won't go into the details here, but I mean, some of these I'm sure be really familiar to you guys who are experienced developers, the Angular, React, Vue, and so forth. Okay, so in the Wolfram Cloud, what we're proposing is, as either a means of APIs, which I'll get into, or as a means of developing your own web application. And this is done exclusively with Wolfram Language, which is the programming language behind the Wolfram technologies. So we're going to create some APIs that can be accessed by any system or user that has access to the internet, some web forms that can be viewed through your web browser, as well as some Wolfram notebooks. And let's jump into that and show what that looks like. So yeah, the first thing that I want to start with is the idea of a Wolfram notebook as a web page. And so in the Wolfram Cloud, we support that. So if you're familiar with Desktop Mathematica, which is what I'm using right here to show this demonstration, then what you could see here is that we could just take this whole notebook that I'm showing you, upload it to the Wolfram Cloud, and then it can be shared with anyone who has access to the internet through the Wolfram Cloud. So I'm going to do a quick demonstration of how we can create just a static web page based on a Wolfram notebook. So I'm going to evaluate this input, and this, for users who aren't that familiar with Wolfram Language, what we can do in Wolfram Language is automatically generate notebooks. And so that's what I'm doing here with this create document function. We have a text cell that's going to have a title format, another text cell that says welcome to this course, another text cell that's saying what I'm going to plot here, which is the sync function, and then this cell right here is going to show that sync function. So let me just evaluate that with my Shift Enter. Okay, and the notebook pops up on my other screen. I'll just drag it over here so you can see it. So here's that notebook that I just created. And I've done this programmatically, but alternatively, I can also add more content to this if I want. So if I want to have, say, like the current time that I created this inside the notebook, I can do that. So I'm going to move that off screen. And what I'm going to do is deploy this to our Wolfram Cloud. And this is a pretty simple step with the functionality that we have built into the Wolfram language. I'm going to authenticate with the Wolfram Cloud. So generally, when you first start using Wolfram language and get connected to, and you want to access the Wolfram Cloud, you would pass in your password as a second argument to this function. I've already authenticated, so my password is cached. And also this is a plain text, so I don't want to share my password with everyone who's watching this presentation right now. So when the response comes back as my user account for the cloud, then I know that I'm connected. And so I can now deploy this notebook that I've created. It's this NB symbol right here is my notebook object to the cloud, and then we'll be able to access it through our browser. So we have a super function that's called Cloud Deploy for sharing a number of different objects in the Wolfram Cloud. So this first example I'm going to show you is just this static web page that I've created. So the first argument to it is that notebook. The second argument, which is optional, is the path or the file name that I want it to be saved as in the Wolfram Cloud. So I'm inserting it in a folder called Wolfram U in my account. And then the file name, I'm going to be calling it first notebook.nb. And I'm going to talk a lot more about the third argument further on in this presentation, but this is the permission. So basically, sets whether or not other users can view this web page that I've created. So let's deploy this. Deploys very quickly. So now I have a cloud object that is returned, which is just an expression in Wolfram language to let the system know and me know that this is a file that is stored in the Wolfram Cloud. And there's a hyperlink embedded inside that cloud object, which is the link to that notebook that I just deployed. And if I click on that, and it will open up in my browser. So here I'm in Chrome looking at that web page, and you can see that this looks very similar to what I had in my Mathematica notebook, which is here. So this is Mathematica, and this is Chrome over here. So I'll slide this out of here. And so this is it, a web page. Now, if I sent you this URL, to those of you who are watching this presentation, any of you could access this web page, or anyone else who has access to the internet can access this page and read it right now, live. So, okay. I'll mention a few other things. So Wolfram notebooks support a huge amount of styling, creating content, and I'm not going to go into much detail, in fact, hardly any detail about how that is done. If you're interested, there's certainly lots of resources that we have available for teaching you how to do that. And I just have another note that much of the functionality of notebooks within Mathematica itself is currently supported by the Wolfram Cloud. And this is an ongoing project that's under development, is to continue to support more and more of the features that are in these Mathematica notebooks. So one of the features that is supported in Mathematica notebooks is interactives. So here's a very simple manipulate that I've created. Manipulate allows me to interact with an evaluation. So I'm giving it a symbol name manip, and it's a manipulate. And basically, I just made this kind of fun GUI to demonstrate, how angry I am today. So right now I'm not angry at all. So I'm going to scale this down to here. So Popeye has light colored skin, but if I click on, any of these buttons up on the top, we can see that the color of his skin is replaced with the color that I've selected here. And that's using one of our image processing functions called color replace. Okay, so now I can also share this particular manipulate in the Wolfram Cloud, much the same way that I did for the notebook that I created previously. So I'm going to use our super function cloud deploy. And the first argument is that object that I've just created, which is this manip symbol. And I'm going to specify the path to it with the wrapped in cloud object to show the cloud where I want this to be saved and set the permissions to public again. Okay, so now this is deployed in the Wolfram Cloud. So if I click on the hyperlink here, it will open up in my browser. And so here I am in Chrome again. And so you can see that the functionality is effectively the same as what I had in Desktop Mathematica. But this is in through my browser. And so again, if you are a very fast typer, you can type in this link and access it on your own browser if you're interested. Let's see, I guess while I'm here, there's one thing I want to add about the URL to these objects so that it kind of helps you remember. So you could, let's see, and this is a little bit hard to see probably, but the URL it starts with HTTPS www.wolframcloud.com, and then the next folder within Wolfram Cloud is objects, and then some variant of your username, because there's only one Chad K, it seems, or maybe I'm the first Chad K user in the Wolfram Cloud. This tells the cloud that this is my files, and then here is where you can see the path that I used in the cloud deploy function, Wolfram U and manip.nb. So this is, if you can remember the first, the base URL path, then you could just add the cloud object path to whatever you typed in, and that's what you can send to your browser. Or of course, you just look at the link that comes back from Cloud Deploy. You can just copy that and paste it. Okay, so that's pretty neat, right? So we've created both a static web page as well as an interactive web page with a couple lines of code. And those are fully functional web pages that we can share with anybody. Okay, so now I'm going to move on and talk about some computations that can be done in the web via APIs. So these can be accessed, again, through your browser or through any other software that can make an HTTP request to the cloud. So this is, so the function that we use for APIs is conveniently called API function, which is analogous to our function named function. So an example of function, right? So function, the first argument is the inputs or list of inputs that go into the function, and the second argument is what we do with that input. So if I evaluate this input here, so now I have a symbol f that has a value of, that it is a function that takes an argument x and squares that value of x. So if I evaluate that function f with input 3, it squares it and gives me the result back as 9. So API function is going to be similar to that, but there's a bit more sophistication in the way that inputs are handled, because these are coming through the web rather than through, or necessarily through, the Wolfram language itself, right? So they can come from JavaScript or any sort of other programming language that is making HTTP requests. Okay, so the inputs, and this is not that easy to read, but this is from the documentation. So the inputs are, again, it's similar. The inputs to our function of API function, the first argument is going to be this list of name and type values, and then we have our function, and last we have some other options for how we want this to be outputted. So the name of the name key here inside API function for the first argument is the parameter name for an input. So this could be, if it's going to be a function like we have above, it could be x, be a username or a city or building number or anything like that. So basically, however we want to define that symbol inside our function, which we'll talk about in just a second. Type is a shorthand for our interpreter function. So the data that's coming into our API function is basically a string. And so Wolfram language needs to take that string and parse it into an expression that it can use for computations. And the way that's done is with our interpreter function. And there are a number of interpreter types that are supported for parsing the data that you bring that is brought into these APIs. So some common ones that are pretty expected, numbers or strings. So if I have an input that's coming as a string that looks like a real number, I can use our interpreter function with the interpreter type of number and pass the input as the argument to that. And you could see that we have the result that comes back is this number. And if yeah, I'm post-fixing that with input form to show that this is no longer a string. So if there's a string, there would be double quotes around it. So I can do an evaluation on that. So another way that we can look at that is if we want to add something to it, right? So that's a number 22.4 plus the number 1, and we can just do an evaluation right on that parsed expression. Okay, so and we can be more specific than number if we want. So if it's an integer, then what will come back is an integer. And let's see, I guess I don't have it here, but if I evaluate this here with an input that's actually not an integer, right? So in this case, I've provided an argument as 12.1, which is not an integer. What will come back is a failure. So this is kind of a helpful way of checking to see if the inputs that coming into these functions are what we expect. So a string is another input. So if we pass a string into the interpreter and we want to keep it as a string, it's just basically left alone. And then once we get into actual web applications, then things like JSON are really useful to have. So if we want to pass in a JSON object to our API function, we can do that as well. So I like to use raw JSON because what comes back is an association, but you can use JSON, and I think there's also JSON expression as well. So in this case, so here's my JSON object as a string, right? So I'm using these escape characters to denote that A is a string here, then A has a value 3 and B has a value 4, right? And so now I have that as my result. And so if I want to know, what the value of the A key is, I can evaluate that, and it's 3, where this % is referring to this last input. And just for fun, we support a whole bunch of other different things. I'm just showing you some other ones. So we, if you send the bytes for a image file to a API function, we have an interpreter for that. So in this is an example here where I'm creating the bytes by doing an export string of a random image that I create in PNG format. And if I pass that through our interpreter, what we get back is this random image that I created. We also have held math expression. This is kind of useful for if you want to have some sort of online course for having students answer mathematical questions. Right, so this is, they can type in something that's actually not a Wolfram language expression, and this gets converted to a Wolfram language expression, and it can be held or not held. So if we want to hold that and simplify this expression 4 plus 3 to 7, then we get, sine of t to the 7th power. Okay, so that's the input part of the API function. Now we have, I'll talk about the functions in API functions. So here's an example API function. So in this case, my input is the parameter x, and it's of type integer, and I'm just going to square it. And so we're using a slot notation and an ampersand to denote that this is a pure function. Or actually, it doesn't necessarily have to be pure, but it is a Mathematica function. And the slot tells the system that this is a parameter that's coming in as an input, and then the label goes right next to the slot. So there's no space between these two. So this is slot x referring to this argument that's passed into the API function, okay? So if I evaluate that, so now the symbol API is this API function, and then I can pass in an association with this key value pair of x going to 10, and actually just probably should have this as a string, although that doesn't really matter within Wolfram language. So if I pass in 10 to my API function, it gets squared and the result is 100. Okay. If I pass in now 1.5, and again, let's put that as a string just to be more precise and more web-like, then I get a failure because this is not interpreted as, we're not able to interpret 1.5 as an integer, okay? All right, and if I wanted to accept a real number as an input, I would just change the interpreter type here to number rather than integer. Okay, so here's an example using a string. So I'm just going to do a string join on the name here, and add exclamation mark at the end. So here's my full function that I'm going to evaluate. So then if I pass the name as world, then we get our classic hello world evaluation. Okay, and so just one example here that I just wanted to show that, in some other languages, using an underscore is supported as a symbol name. In Wolfram language, the underscore denotes something very meaningful, which is a pattern. So we can't just apply slot to this name, but if you wrap this name, leave it in string, and then wrap it with square brackets, then it can be evaluated. And one other thing I'd like to specify is that the function that's in the API can be defined outside of the API. So if I want to define some function, get building data, so let's say building 3, we'll say that's red, okay? And so here's kind of a crude way of defining this function, okay. Okay, and you can see that, so inside my API function, it has this, the function name here without its actual down values. But if we evaluate that, again, we'll get some numbers in here. And I've only defined for values 3 and 5. So 5, oops. Oh, right, sorry. This should not be, this should be building number. The parameter is not X. So this failed, right, because there's no input for the field building number. So now if I provide the building number, now you can see that the building data here that I've returned is empty. Okay, so some other notes here that the function does not have to be a pure function, right? So we can actually load data or save data at runtime, and I'm going to show an example of that when I get into the forms. And the definitions for any symbols that are used inside the function are automatically saved along with the API when we deploy it. So right now, because I'm in the kernel session, what you just see here is that this is pointing to this symbol name right here, but the definitions, because they're in the kernel, we don't need to explicitly point them out here, but when we deploy this to the cloud, we will. And I'll show an example of that for form function. Okay, and so the third argument for the API function is the output formats, and there's a number of options for the different types of outputs, and that's described up here in the documentation. If you go to the documentation page, you'll be able to see it. So, but what I'm just going to show is this input form where we just specify the output format for the function. We can have response format and fail format and so on, but you can read about that in the documentation, I think, later. I think we'll just move on about that. But so the output format, so some of the common values that would be used, again, it really would depend on what your function is returning. So Wolfram Language, this is a shorthand for Wolfram Language. Coming back, JSON is supported. You could create an image, basically rasterize whatever the output is, or create a notebook. A Cloud CDF is kind of a shorthand for creating a notebook. So in this example here, I'm going to just output JSON. So here's my input. So X is a number, and then my function, I'm creating an association where the first key is just the input value, and the output value is my input squared. So again, it's, rather simple functions, but much more sophisticated functions can be supported here. This is just a training class, so we're not going to show too many really sophisticated functions inside this argument. So even though I've specified JSON, you can see that what has come out is actually Wolfram Language expression. So if I'm evaluating an API function within Mathematica itself, then this argument is ignored. So let's deploy this API function to the cloud, and then we could see that in fact JSON is being returned. So here's my API. So now I need to provide this API with an input in order to evaluate it. So I'm just going to use some of our tools to build GET request for this API. So here's my cloud object, and I'm going to provide the parameter value of 4 to that. So now I have a hyperlink that I can click on and open this in my browser. So now you can see I called this JSON API with the argument x equals 4. And here's my output response, which is in fact JSON, right? So here's my in with value 4, my out value of 16. Okay, and if you want to do that within Wolfram Language, so we can use our URL read function with the HTTP request on this cloud object, passing the values into it and look at it. And in that case, again, you see that this is a JSON string that's coming back. Okay, so moving on to form function. So form function, like I said previously, is actually, I guess I didn't say this, but this is a form. So we're creating a web page that accepts user input. So the structure of form function in the Wolfram language is very similar to API function, but there's of course a lot more support for styling and adding different features to the web page. So just as a quick example, I'm going to show a survey. And so in this survey, I'm going, well, let's see. Yeah, so the survey is, the general idea is I want to send out a survey to some of my friends and ask them what the best day for a party in the month of July is. So the 14th, the 21st, or the 28th. So they're going to see a form on the web where they could type in their name and then pick one of these 3 dates that works best for them. And this is, so this notation here where we wrap possible options in a list is an alternative to using our interpreter function. So this denotes that these are the only options that are supported for this. And this, generally would be more appropriate for something like a web form where we're gonna have a pull down menu to look at the options. Okay, and so this is an example where, yeah, this is not a pure function. So I'm going to be saving data and as well as reading data from another source in this form. So what I'm doing is tracking each person who has submitted this form, their name, and then what their preferred date was. And the return that I'm going to show them after they've submitted this form is a bar chart. And so I'm not going to evaluate this right now because I do have some data that I've saved in this from deploying this prior to the course. But if you want to initialize it, we could do that. So you could see that here I'm reading data from this cloud object using our get function. So this is just basically reading in the data that's stored in this file. So when I first deployed this form, I initialized the data as being empty, so there's no data in there. And then once the new data from the user is provided, then it gets appended with this to the data, and then I save it again, and then I do my counting on which dates work best and provide a bar chart. Okay, so let me deploy this form. Okay, so actually this is just creating the form. Now I will deploy it. And so what I've done here, so I did not overwrite this file right here, which has my survey data, but I did overwrite the form itself, just basically creating a new copy of it. Okay, and so I can click on that and go to it on my browser. So let's see, I'm going to pick for Lynn, who's one of our developers who's listening right now. I think Lynn probably would, let's say he wants to go. Now I think I already picked July 21st. So Lynn picks one of these. So you can see my drop-down menu for the 3 options that I specified and typed in Lynn's name. And this is just a string, so you should be able to submit and this should work. And now you see what has come back is this bar chart with July 14th, July 21st, and the 28th. And I've only submitted 3 times, so the one that Lynn picked is now the favorite. Hopefully he's okay with that. And so again, this is an example where we read data from a file that's stored in the Wolfram Cloud, and then we've saved data to that same file again. Now, as the owner of this API, right, maybe I don't want to go back to the form and then after I've submitted my favorite, I want to know actually what the data is. I don't want to corrupt the data by adding another fake name to it. So within Wolfram Language, or in fact, if you want to do this in the Wolfram Cloud, you can just evaluate this code to get the data from there. And then this is just the evaluation that I'm doing inside the form itself to create the bar chart. So hopefully this works, yeah. And so you can see here's the bar chart as a Wolfram Language expression that's come back by reading the data from that file. Okay, so let's see. I guess I'll show this. So as an example of a little bit more complicated type of form, actually mostly as a, yeah, complicated form, I guess, for what you can do in Wolfram Language. So our developers have created the image identify project. This is a machine learning neural network that can identify various types of images. And I think it's broken here. Yeah, so I need to upload an image from somewhere else. I guess I could do that really quick. Okay, so yeah, here's a red panda. And let's see, how can actually I know, here, put this over here. Okay, so I've uploaded the image to this form, and then I get a response back, and you can see that our internal function or Wolfram language function image identify has viewed this image and interpreted that this is in fact a red panda, and it gives me some additional data that's coming from Wolfram Alpha. So yeah, as a challenge for some of you more advanced users, you could think about, how would you code the functionality of this page using form function? Okay, so just as a hint to get some of you guys going, so the first argument is going to be, the input to the function. So it's going to be whatever parameter name you want to give it. It could be image or so forth, and then the interpreter type, which can be, any sort of image, or just capital I image, like I used in that previous slide. And then you need to have a function in here that does image identify, and then so on, whatever level of sophistication you want to have for sending the data or telling the user what type of image they've identified. Okay. We have some very helpful tutorials for creating more advanced web forms. So I have a link down here. I'm not going to show it right now, but to give a lot more styling, more sophisticated web forms where you might have more than one input that's provided, or nested forms. So, you type in one input and then that leads to you to adding another input and so forth. We also have the ask function, which provides a bit more functionality. This is still, I believe, experimental. But yeah, if you want to use or create forms with Wolfram language that are more sophisticated than just a single input or a single set of inputs and a single output, we do have tools for doing that. Okay, so we covered the basic pieces of that we're going to be kind of highlighting later on. And but first, I want to take a brief detour to talk about the security of these deployed web pages and deployed APIs that we've created. So, in some cases, it's fine to leave them open so that any person who can access the URL is able to evaluate them. But in other cases, we want to protect the data that's inside, or just prevent other users from accessing them. So the way that that's done is that, if you recall from the cloud deploy function, is that third argument has an option that the permissions can be specified in. So there's sort of really high level options for cloud deploy. So public and private being the ones that I demonstrated before were public. But some of the other high level one is private. And then we also have subcategories that, again, depending on the type of resource that you've deployed to the cloud. So read, write, execute. So in the case of an API, right, so maybe you want to prevent users from reading it. You definitely want to prevent them from writing it or changing some of the code that's inside. But you might want to allow them to execute, so you can specify that they can execute only. I have some examples of that further down. So if it's public, right, then no authentication is required. If it's private, then only the owner can access it, and the owner must be logged into the Wolfram Cloud. So if I deploy this very trivial API function, which just returns the time, right, and I click on this, then you can see that for me, this is working because I've authenticated in the cloud. You could see, oops, I go back to the original landing page for the Wolfram Cloud, you could see that I'm logged in here. On the other hand, if I go here, and I don't believe, so if I use let's use Microsoft Edge, I don't think I've used that. So if I try to access it, right? So if I try to access it here, then I get redirected to the sign-in page because I'm not authenticated, right? And if you are authenticated and you're a different user, then you'll just get an error message saying that you can't even access this page. Okay, but we also allow support for specific users. So if you just have a list of users that should be able to view or execute view a web page or execute an API, you could provide that as an argument to the permissions option. So in this case, I'm showing a list of 2 users, Jan at wolfram.com and Joe at wolfram.com, and I want them to be able to execute this API. Okay, another sort of level of abstraction beyond that. So let's say I have a number of different APIs or web pages that I want this same set of users to be able to have similar types of permissions on it. We can create a permissions group that has a name and then the members of it, and then we could just either just set the permissions with here, or we have another function that's actually if you want to change the permissions of a deployed API or notebook later, you can use a set permissions function and then provide the permissions as the permissions group, and then provide what type of or specify what type of permissions they have. So in this case, I would provide read and execute permissions to those users. So one intermediate level of security that we provide is this permissions key. So this is, like I said, intermediate level. So the API itself is open, but in order to get the value of it, we need to provide a key value pair for it. So here's an example of this. So again, the same thing. So we're going to just return the current time in this ISO date time format. And the permissions here is the permissions key. And the argument to permissions key is the key value itself. And so whoever passes this secret key value has execute permission. So let's deploy this API. Okay, and now if I make a request for this API, so I'm using first here so that I don't pass in any of my authentication credentials to this API, because this is basically a public API, except that it requires this key value pair, and the key is this underscore key, and then the value is the value that I specified above here. So if I evaluate this, then you can see I have gotten the response back. Now, if I pass in a wrong key to this API, you can see what happens is that, right, I'm getting an error message, right? So it tells me that I passed in an incorrect permissions key. Okay, so I'm just doing this post-fixing of what comes back is actually HTML. So I just want to be able to read that nicely in Wolfram Language. So I import string as HTML. Okay, so that tells me I got it wrong. So if this is the wrong key, if I give it the right key, then I get the correct value. Now, in the case of notebooks, there's some additional interaction specifications. I won't go into these very much or even really show you any examples, but because there's a lot of different things that users can do with a notebook, we allow more specific granularity on the types of permissions that you have from interact, which is, as I showed, that Popeye example earlier, being able to pick different buttons for the input, evaluate the code, edit it, save the notebook, create a cell, delete a cell, and so forth. Okay, so now I'm going to show you an example that I created for a customer that involves both calling Wolfram Cloud APIs from a web application, as well as actually hosting it in the Wolfram Cloud, which is an option, but is not necessarily required. If you have an existing web application and you just want to call Wolfram Cloud API, that's very viable way to do it. But in this example, I'm going to show you can actually host it in the Wolfram Cloud. So just as a word of caution, right? If you do need authentication, then your server-side code does need to perform the authentication, and depending on which language you're developing on the server side, you need to pass that authentication through that language. Okay, if the output for your API is a notebook, then iframe is a very useful tool to use, so that you just basically provide a window in your web application that shows the notebook that's hosted by the Wolfram Cloud within your application. And what I'm going to show here is an example of that. So, and finally, the hosting the full application. So in the Wolfram Cloud, you can upload HTML, CSS, and JavaScript and then deploy APIs. You can store data in the Wolfram Cloud, as I showed with that survey example, or in Wolfram Data Drop, which I won't go into here, and the APIs. Okay, so I'll just quickly go over this web page that I created. So in here, you can see that there's kind of a form here with different options. Some of these menus aren't populated until I've uploaded a file. So this upload file calls one of the APIs that I've deployed on the cloud, and this update plot calls a second API. So I've set it up so that I don't actually need to upload a file. So if I just click on this, it calls the API. And now I have options for the different menus in here. So I think if I just set a couple of these guys, yeah, that should be fine. So now I basically filled out the form with kind of a default set of parameters. And now if I click on the update plot, what should happen is that I get a 3D plot from the Wolfram Cloud. And so this is in fact hosted by the Wolfram Cloud. So you can see this is my demo.html, and it's in my folder Wolfram U in this web app folder. And the APIs are deployed somewhere in this folder as well. If you're interested in looking at those, I mean, we could look at this inspect option for Chrome and look at network, and you could see which APIs are being called here. But in the interest of time, I'm going to kind of gloss over that. So yeah, so what's come back is this notebook. And why is it a notebook? Well, it's a notebook because I want to be able to, or the user actually, or owner of this web application wanted to be able to manipulate the 3D object. So this is one of the powerful features of the Wolfram Cloud, is that if you have a 3D plot, we are able to look at it from any angle that we wish. Okay, this is not just a rasterized view of the plot. Okay, so yeah, again, there's two APIs here, and those are both deployed with Wolfram Language. There's HTML, and there's a little bit of CSS, obviously not a whole lot. There's not much styling going on here. Okay, so yeah, this could be done. And again, the HTML can be on a totally different server, and you just need to make requests to that Wolfram Cloud if you already have a web application. Okay, on the other hand, and this is one of the ideas that we've been trying to emphasize about the Wolfram Cloud, is that you can actually build a full web application with just Wolfram Language, right? No HTML whatsoever, and that works, and that can do some pretty sophisticated things. So one of our developers, Jan Peshko, created some source code to create a blog in Wolfram Cloud. And so here's a link to the repository. I don't really have much time left, so I want to leave a lot more time for Anthony and some time for questions. But if you click on this link to the repository, you can see the code. It's publicly available to create your own blog. Just follow these steps, evaluate the code. It's a Wolfram Language package, right? So it's all Wolfram Language. Write a post, which is just to create a notebook in Mathematica or in the Wolfram Cloud if you prefer. Either way is fine. Upload that notebook to the cloud if you've not created it up there. Put it in the content folder of the blog, and then evaluate the following code. So, which is basically just sources. Tell the blog that the sources. Here's the notebooks that I've uploaded. I'll click on the links to show you in just a second to get the sources that you need. And then this sources is actually used as a kind of a hidden argument to this deploy function which then creates the different formatting that we see. So let me I'll show you my first post here. So this is just a notebook that I created in Desktop Mathematica, and then I uploaded it to the cloud. So, but you can see that, yeah, here's in the content folder, which is what Jan's instructions told us to do. And it's very, very simple, right? So it's just one text cell and then this now input cell, which in fact, I think that I can't evaluate because the permissions of this notebook, again, this is something I talked about in that permissions page. It's not set for evaluating cells. Okay, so that's the notebook that I uploaded. So now let's look at the blog in its current state. And again, I'm not showing you the details of how this is created. Hopefully you'll have a chance to take a look at this on your own time. So you can see that what has been done here is that the only thing that that I've done on my end is to create and upload these notebooks, and then the code that Jan has created has assembled those notebooks into a single index notebook page where we can click on read more to look at the full post. So I already showed you the first post, which is not very useful, but so I look at the back for more posts, I can click on this read more link, which will open a tab to the full notebook that the full notebook content that was created, but also it has the header still for the blog. And the interesting thing here as well is that so we can have an interactive in here. So you saw in the last one that you can't evaluate inputs, but the default permissions for this blog are that you can interact with it. So this is a working web page with Wolfram Language evaluation that can be interacted with, and then we can leave comments in it as well, which is kind of fun. So if you can access these URLs or create your own blog, then people can comment on it, right? Okay, and there's a lot, a lot of details that I'm really glossing over here. So I hope that you have some time to take a look at this repository and take a look at the code yourself. So for those of you who do that, some of the things you can think about, like what could be done to improve the blog. And maybe you could pass on those suggestions to Jan or a cloud developer team. So in conclusion, so the Wolfram Cloud supports multiple architectures for web applications. So we've seen that where we support API functions, form functions, standalone notebooks. Notebooks can be bundled, right? We can have external web applications evaluate APIs that are hosted on the cloud. Any of these sorts of things are supported in the Wolfram Cloud. And here's some link to some resources that are available. There's a whole bunch more that I'm not really listed here. But yeah, if you haven't tried the Wolfram Cloud, be sure to try it out. We have a free open cloud that is open to anybody that you can try and do some of these evaluations that I've shown in this presentation.